Very good morning, guys. We are going to start carbohydrates from today. So I know we are starting very late because as of now you are not like you are not having any preparation for semester 3, which is going to be in your February end or March. So let's start with carbohydrate. Unit 2 of biochemistry. I am starting with carbohydrate because I think this is important than the first unit, more important. So, what do you mean by carbohydrates? Leave the S for now and think about carbohydrate. What do you mean? Carbo means, yes, so hydrate of carbon. Carbohydrate means something you can say as hydrate of carbon. Yes, it is hydrate of carbon. So its general formula, we are going to see a general formula of this hydrate of carbon, means carbohydrate. So you can write it that general formula of carbohydrate is CxH2OY. So over here this variable keeps on changing. So as of now, in this 1 minute, what you have understood, we have started unit 2 of biochemistry and it is carbohydrate. What do you mean by carbohydrate? It is hydrates of carbon and its general formula is CxH2OY. This X and Y is variable, it keeps on changing. So this formula has an exception. So obviously biochemistry, the word chemistry comes here, isn't it? Biochemistry. So chemistry has exceptions, so this biochemistry also have exceptions. So what are the exceptions? Some non-carbohydrate molecule also follow this formula. So you can say as of now that what non-carbohydrate molecules can follow this formula. So exception example I am giving. So you can give a heading that exception. Okay, now exception number 1. So non-carbohydrate molecule. So you can start as of now like this. Exception non-carbohydrate molecule. Write it, non-carbohydrate molecule that follows that follows this formula. Okay, that follows this formula. What example? Let's see. Formaldehyde. Formaldehyde formula is HCHO. So sorry, HCHO. So in this HCHO, arrange like this: C1 H2O 1, X equals to 1, Y equals to 1. So according to this formula, general formula of carbohydrate, this formaldehyde may be a carbohydrate, but no, formaldehyde is not a carbohydrate. So this is the exception over here. Now let's check number 2 example. Number 2 example, if I talk, then number 2 example, you can take acetic acid. Okay, acetic acid. What is the formula of acetic acid? CH3COOH. Okay. So carbon 2, H2O. H is 4 and oxygen is 2. So this way you can write that X is 2, Y is 2. So according to this general formula C6H2OY, this is also a carbohydrate, but this is not. So this is one exception, that the general formula is not always applicable. Now if I come to exception number 2, this was whole exception number 1. Okay. Now if I talk about exception number 2 as a whole, then there are also some carbohydrate molecule which do not follow this general formula. This CxH2OY, this general formula is not followed by some carbohydrate molecules also. Let's see of deoxyribose. If I talk about deoxyribose, okay, just write it. When you will practice the structures, you will come to know. Deoxyribose formula is C5H10O4. So this does not follow this one, H2OY. See, you try of putting in this C5H10 and O4. How it will fit in this? Not possible. C5H10O4. If I talk about ramnols, it is C6H12O5. So again, this is not followed, this formula is not followed by this or this. So these are the two types of exception. One is non-carbohydrate molecule follows this general formula, other is some carbohydrate molecule do not follow this general formula. So this is all about, like, starting class में और क्या ही बोल सकते हैं. These are all the basic ideas which you need to grasp before starting the chapter. Now so this was earlier considered that in this general formula is for carbohydrate, but now we are modern, so obviously there are modern definition of carbohydrate. So just give a heading as modern definition of carbohydrate. Modern definition of carbohydrate. So let's go on with modern definition of carbohydrate. Modern definition of carbohydrate is three things you need to consider. One, the carbohydrate should be optically active. Two, the carbohydrate should have more than one OH. This is polyhydroxy group. 3, the carbohydrate should have ketones or aldehydes. So this is the modern definition of carbohydrate, that it should be optically active, means yes. Okay, I will explain what do you mean by optical activity. And polyhydroxy, it should have more than one OH. Ketonic group like this one, it should have aldehyde or this one. These 2 points are clear. Now what is optical activity? Chalo. When the solution of compound plain polarized light is passed, when from a solution, if you am having a solution, okay, so this is a solution and you are passing plain polarized light. So when from a solution plain polarized light is passed and this solution changes, light is passed, then some compounds are present in this plane polarized light which changes the direction of the plane polarized light. Okay, which changes the direction of the plane polarized light. That is optically active compound. So that is optically active compound. And when there is no change in this direction of light, then it is not optically active. So it is optically inactive. So when from a solution you are passing a light, if the direction is changed, then that compound is called optically active. Now if I talk about, suppose I give you a light over here. Okay, chalo, I gave you a light. Now you are passing it through a polarizer, plain polarized light you want, so you are passing it through a polarizer. Now you are getting a plain polarized light this way. Now it is passing through a solution, so the light is rotated this side or the light is rotated that side, or the light remains same. So when the light is rotated towards the right, then we call it small d or plus dextrorotatory. Write it, dextrorotatory, d dextro. And when the light is rotated towards the left, we call it sleevorotatory. Okay, and this is optically inactive. Okay, optically inactive. So this is all about this one, optical activity. What is optical activity? You understood? Okay, so optical activity of a compound, criteria to satisfy. Okay, so Now this optical activity is what you have understood, but how you can prove that optical activity of a compound, how this is optically active, why the compound is optically active. So uh, if the compound is optically active, then it is having chiral carbon. So what is chiral carbon? This all four different groups it is having. Suppose this way, all the things are different, all four different compounds. So this is chiral carbon. When there is lack of symmetry, means O, if I draw a letter O, okay, so you can divide it. This is side is same, this side is same. So this is optically inactive because this is having symmetry. But D, if I divide D, it's lack of symmetry. So this is obviously a what? Say, this is obviously lack of symmetry. So how you can say that a compound is optically active? When a compound will be optically active? When it is having chiral carbon, presence of chiral carbon, and when there is lack of symmetry, when there is no symmetry. So there will be no symmetry. Okay, so this is what I am trying to say, that this is called optical activity. If I take a example of a compound, chalo, I took example of O letter, D letter. Okay, suppose I am taking A letter. Okay, these two sides are same if I divide from here. So this is lack of symmetry. No, this is symmetry. If I taking P, then there is lack of symmetry. Okay, but in chemistry letters don't work, right? I have to take an example of compound. So chalo, let's take an example of compound. Till then you can take a screenshot of this page. Now let's take an example of, suppose if I take an example of tartaric acid. Okay, if I talk about tartaric acid is of two types. One is meso tartaric acid, okay, and other is optically active tartaric acid. So this is like this one. Okay, both side you have COOH, one you have OH. Okay, other side you have OH. So if I divide, both sides are same. Okay, so there is symmetry. So this will not happen optically. You can write over here that this is optically inactive. But if I talk about optically active tartaric acid, then it is like this: COOH, COOH, HOH, OH. So this is, there is lack of symmetry. Lack of symmetry. And if I talk about this carbon, this is having one COOH, one OH, and this totally different thing. So this is chiral carbon. If I talk about this carbon, this is also chiral carbon. This is having this compound at one end, H at one end, COOH at one end, OH at one end. So this compound is optically active. I can say this as optically active. Understanding it? Okay. Now let's check one structure of glucose. Chalo. So if I check the structure of glucose, it has 6 carbon. Okay, glucose structure, Fischer projection, almost every one of you know. If you don't know, then learn it here. Okay, glucose, and then I will make you understand all the structure family, Fischer structure. Okay, it is CHO, CH2OH, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and one more 6 carbon. 1 2 3 4 5 6. Okay, Now H, OH, isn't it? H, OH, H, OH, OH, H. So this is your glucose. Now, why is glucose a carbohydrate? Chalo, let's, whatever I have taught you from till now. So first is it should be optically active. Let's check. If I talk about this carbon, CHO, OH, H, whole different group. If I talk about this carbon, OH, H, different group, isn't it? If I talk about this carbon, OH, H, different group. If I talk about this carbon, this group, different group. Isn't it or not? So, any carbon optically active, it's done. No need to check so much. Check one, okay, then go to the next. Next condition, it should be polyhydroxy. Remember? Okay. 1 OH, 2 OH, 3 OH, 4 OH. So obviously this is second criteria also satisfied. Third criteria was ketone or aldehyde should be present. Aldehyde group is present. So all the three criteria are matching. So glucose is a carbohydrate. Understood? So glucose is a carbohydrate. Now students, till here was very basic idea about carbohydrate. Okay, now we are going to see carbohydrate classification. Okay, so when I talk about carbohydrate classification, so this I have created for you, so let's check it. Just for understanding, no need to learn, just keep the basic things in mind. Okay, chalo. Carbohydrate classification. Okay. So if I talk about carbohydrate classification, you have two things. One is sugar, other is non-sugar. Sugar, sweet taste, soluble, crystalline. Non-sugar, no sweet taste, solubility sparingly soluble, little soluble, and non-crystalline. Understood? Okay. Sugar is of two types, monosaccharide, oligosaccharide, and non-sugar is of one type, polysaccharide. Monosaccharide is single sugar unit, oligosaccharide is more than one sugar unit present in the structure. And when more than one sugar unit present, how it is joined? With the help of glycosidic bond. Understood? Okay, chalo. Now polysaccharide, when more than 100 sugar units are connected, this is more than 1, this is more than 100. Large polymeric structure, presence of glycosidic bond. Similarly, the sugars are joined with glycosidic bond. Now if I talk about monosaccharide, single sugar unit, this monosaccharide can be divided into two parts based on carbon number in structure, based on functional group present in the structure. Carbon number present in structure we divide as triose, tetrose, pentoses, hexoses, heptoses. Okay, triose, tetrose, pentose, hexose, heptose. And another triose is singular plural. Okay, tetroses, pentoses, hexoses, heptoses. Based on functional group, we divide it as aldehyde and ketone group. Okay, based on functional group, aldehyde and ketone. So aldose sugar, aldoses, ketose sugar, ketoses, ketose, fructose. Okay, now okay, if I talk about example of this, we have glyceraldehyde, erythrose, ribose, deoxyribose, glucose, galactose, fructose. Okay, now this way you can go with example of triose and tetroses. Okay, and aldehyde is glucose, ketone is fructose. Attachment of different group, this group is attached fructose, this group is attached aldehyde group, aldose, ketose. Okay, this you will remember when I will do the chart. You will remember 3 carbon, 4 carbon. Now when I talk about oligosaccharide, presence of glycosidic bond is there, more than one sugar unit present. So 2 sugar unit connected together, disaccharide, 3 sugar unit trisaccharide, 4 sugar unit tetrasaccharide. This only this in syllabus. Disaccharide, sucrose, lactose, maltose. Only single monosaccharide unit joined multiple time. Okay. So no, don't look at this, I'm sorry, till here. So two sugar unit connected together, disaccharide, sucrose, lactose, maltose, these three are in syllabus. Three sugar unit, four sugar unit not in syllabus of your. Now you have polysaccharide, more than 100 unit connected based on structure, homopolysaccharide, heteropolysaccharide based on function, structural cellulose, and this we have storage poly. Okay, so storage polysaccharide, structural polysaccharide. So polysaccharides type, oligosaccharides type, monosaccharide type. Okay. Um, Now, when I talk about all this, you will understand. Don't go in this. If you want, you can keep this chart with you. Later on, you can just go through it once. Okay. Why not 2 carbon act as carbohydrate? I have one question for you. Let's see why not 2 carbon. I have taken this CHO. I have taken CH2OH. Okay. Uh, if I talk about chiral carbon, this carbon is having 2H. If I talk about this carbon is having H, this carbon is having O, double bond O. Okay. Now polyhydroxy, only one OH group is present. How 2 carbon can be a carbohydrate? So 2 carbon is not a carbohydrate. Hence over here monosaccharide, when I am talking, we start with triose based on number: triose, tetrose, pentose, hexose, heptose. Okay. So this was all about what classification you need to do. And let me simplify this in the copy by writing it if you want. Okay. So let's simplify carbohydrate classification. Okay. Like me, you need to maintain a rough copy. If you do not practice biochemistry like this, you will not be able to pass. So carbohydrate classification is of two types. One is sugar, other is non-sugar. Right, like me. Non-sugar. Sugar, sweet, soluble, crystalline. And this one, just opposite, opposite, opposite. Okay, okay. Sugar can be of two types: monosaccharide, one word, and this is oligosaccharide. Non-sugar is of one type, that is poly. Now monosaccharide can be divided on the based on carbon number, like triose, tetrose, pentose, hexose. But why not 2 carbon? Why? Because I told you CHO, CH2OH, 2H group, no chiral carbon not present, OH polyhydroxy group not present. Okay, so this why no, we to start with triose, that is 3 carbon compound, and based on functional group, we have many, like this 2 we have aldose, ketose. Okay, so like CHO and this one connected. So aldose, if I take an example glucose, you take an example fructose. This much you remember. Okay. Oligosaccharide, if 2 carbon is at more than 1 carbon attached through glycosidic linkage. Okay, 2 carbon we have disaccharide. Okay, this we have in syllabus. Polysaccharide, based on structure and based on function. Okay, based on structure we have homo and hetero, and based on function we have storage and structural. Okay. You can tell me an example of homopolysaccharide and heteropolysaccharide. Means homo, hmm, one more than one sugar unit connected, but only one single type of this different type of storage polysaccharide. You remember glycogen, cellulose? Yes. Structure polysaccharide you have studied in SEM 2, chitin, peptidoglycan in the cell wall. Okay. So this is okay. Now let's do in the next class, we'll do aldose family tree and ketose family tree. Very important, we will learn that together, and if we are done with that then we can go on with the carbohydrate. It is very easy. Okay, chalo, thank you.